as an OWASP chapter, we were approached by a nice person from semgrep, and she proposed us to do this meetup about semgrep, and it was quite long ago, like many months ago, and I had this discomfort because actually OWASP meetups or OWASP meetings, they should not be a platform for marketing speeches. And in my definition, if you have a meetup with one presentation about one product, that's definitely by definition is a promotional event. And as such, it does not fit the OWASP regulation because that's the official regulation of OWASP that we should not do marketing speeches on OWASP meetings. But first of all, I very much like semgrep personally, like not being that much professional in the I'm not that much professional in the topic itself, so that's why we have Péter on board here, who will be representing OWASP chapter on our side or on our behalf. And Péter's role is to bring objectivity to our session. Actually, sorry, because I was sad that there are some problems with our video or something, but I cannot notice that problems. Bence, can you notice any problem with my?
Your video is okay.
Okay. So hopefully it's okay now. So returning to my point and why I try to be short, but in short, the idea is that in order to balance the promotional formally nature of that, we have a presentation of a product here, even if it's the free open source and whatever. Liked by everyone product. So we have a moderator who is Péter Nyilasy, who is here. Yeah. And Péter is a specialist in code reviewing and security code reviewing. So Péter and Bence and Johan already communicated before to make some preliminary or to provide some preliminary feel for Péter about the product. And I also, good evening, Janis. So we also had a discussion tonight on the OWASP leaders page. Hi, Dominic. And to my surprise, when I announced my concerns regarding the promotional nature of such a meetup, there were more than one or a number of people who were very so they were aggressively protecting semgrep against my accusations that any kind of promotion to semgrep is like propaganda for or marketing for semgrep. And actually, I just tried to check what was said is that what you do, guys, at semgrep, it's just game changer. They wasn't using that word, but I was told that what you are doing, it's like very important in the course of like developing the security review overall. So one of them is writing that this is, so I will do everything I can to push semgreps anywhere. I can and suggest those of you who understand the inner workings and challenges and expense of static analysis, rule creation, to do the same. So,
so just to confirm, sorry, like none of these people were from our team, right? These were other people.
No. Again, it was me discussing semgrep, the ethicality, if I say the word right, the ethicality of representing a product at the OWASP meeting, and this I discussed on the leaders list of these OWASP leaders, other chapter leaders and other project leaders. So and again, a quote: "Semgrep is the most significant advance in statistic analysis in a decade, and it's all open source." So please welcome Bence to represent or to present your semgrep marketing and promotional speech. Peter is with us here to sometimes ask questions, like very, very friendly questions, I guess. So Peter, could you just tell your initial words? What was your impression with trying semgrep? I know that you were not using it like very extensively, but the first impression, what was your first impression, Peter?
Yeah, so my first impressions were also really positive. I tried it. I think we can discuss it later, but I like that you have a nice tutorial which helps learning the syntax of semgrep, and I also like the syntax. It's easy to learn, and at the same time it's really expressive. So I also found it a very useful tool. Yeah, and I also have some questions, but I would like to ask them later on. So I suggest, Bence, that you could start now. And
yeah, Bence, the floor is yours.
Wonderful. Thanks so much for the intro. Yeah, and thanks for, after all, allowing us to talk about semgrep here, even though it's maybe a moral gray area. I promise I will only talk about all the open source stuff that we've built. Basically, everything we've built so far is open source. So I think I'm just gonna share my screen to give like a real quick intro on like what the whole concept is, because like we talked a lot about like what other people say about semgrep, but I don't think most of the audience knows what it is. And I think I need to ask for permission to share my screen. So could an admin or host of this meeting please give me that? It just says host disabled screen sharing.
Well, it's again my stupidity with Zoom, which again I hate. So Bence, probably I make you the host, okay?
Maybe I can.
And as a host, I guess a host can do what he wants.
Hopefully. Let's see. Yeah, I think, yeah, it's allowing me. And I'm just gonna present my whole desktop because it might be easiest if I'm gonna switch between all sorts of like presentations and stuff. Cool. So that's like our normal title deck, SASTing your code. Let's see if this actually reacts to when I click on it. But like just to give people like a real quick TLDR thing that will let you just leave this talk in 1 minute if you are really not interested in anything more than what semgrep actually is. Let's just assume that you have like this bit of source code and you want to find all usages of a string builder being used. So with semgrep, you can write like a really simple search query, like new string builder ... and it highlights or finds you all the matches in an entire code base where this pattern shows up. And so like these patterns obviously can be a lot more advanced, but yeah, that's like basically the entire point. And let me just like refresh here because I think my presentation tab just entirely froze. But yeah, so that's what we've been talking about. And actually this little snippet that I've been looking at is from Péter's suggested vulnerable repository written in Java. And, you know, I might as well just hold the entire talk without the presentation because it seems like Google Docs is completely broken for me. Oh, there we go. Just need to get a new tab. There we go. Cool. So again, like a quick TLDR. We all know here at an OWASP meetup that it's really difficult to write secure code. There's like existing analysis tools that try to help you write secure code, but like we on the semgrep team just thought they were all like either too slow or too heavyweight or too noisy. Like I remember using this one open source tool, which also has a commercial offering. And the way it worked in CI is you had to like configure what rules you want to, what security rules you want to be scanning on a repository. But when it runs in CI, it like compiles a new Java binary with the rules and the code for scanning that specific repository at that point. And it pushes this newly compiled binary to the CI server, which then runs that. This is like an incredibly complex design. And we just like really wanted something that's powerful, but also designed according to the Unix file philosophy. So like kind of like a lightweight tool that can hook into other things in the command line. And so this is semgrep. So you can use semgrep basically. I already showed you like what it does. Your imagination is probably enough to figure out what you can use it for. You can like find security bugs with it. You can get notifications when somebody adds a new dangerous piece of code and similar things. All right, cool. And before everything, like I'll just try to spend like 3 more minutes explaining the background of like why semgrep is really needed as like a new tool, like what the big idea is behind semgrep. And also give you a quick little history, which I'm gonna start out with. Obviously, nobody cares about who I am really. So I'm just gonna say I'm Bence and I work at this team called R2C. We create semgrep. That down there is our team on a Google Meet call. Somehow I'm always missing from team photos, which might be because the rest of the team is in San Francisco and I've never been able to visit them in person. But yeah, like this, basically this is what the Google Meet screenshot would look like with my face on it. Yeah, so again, open source GitHub repo, that's what semgrep is. You can even see that like it's like a proper mature project, but I don't think it's mature because it has like all those stars, etc. I think you can like really tell it's mature because this is like the directory listing of the root of the repo, and of the first 5 items, none of them are actually the source code. So you can see like this is like an old repo that already has so much process built into it that our source code is like way down here and just didn't even fit on this screenshot. Anyway, there's Johan, who is actually also in this call and we'll be taking your questions. We like to mention Johan because semgrep is a spiritual successor of a spiritual successor of something that Johan made like more than 10 years ago. Basically, he first worked on this tool called Coccinelle, which was used to find security bugs, or like not actually security bugs, but rather like to help with refactoring the code of the Linux kernel by actually understanding the structure of code. Then he started out this sgrep or semgrep repository or project at Facebook while he was working there. And then we just kind of, like he left Facebook, we took that open source project and we decided that this actually needs like 15 people working on it because it has such great potential. And one more background slide before like we can actually hop to more interesting things. So semgrep is able to search like many languages. You can see the list over here on the left. and it is LGPL licensed. So that's like a, again, I have my hands up here. I'm completely innocent. This is an LGPL licensed product or project. All right, cool. Now to like explain what really makes semgrep different from like any other way you could be searching for security bugs, I need to talk a bit about syntax trees. There's a classic XKCD about regular expressions and how they're just like never really the right solution or quite the right solution. In fact, like one of the naive thoughts that someone might have if they decide to like search for security bugs with regular expressions is, yeah, that I'll just use grep. I'll just write a couple of patterns and I'll run them with grep to find whenever something looks like an SQL injection, or even just something simple like whenever somebody tries to log to the JavaScript console or just print some sensitive data out. It's like now you might try to write like some really simple regular expressions, like calling a print function, but instead of like 100 problems, you're gonna get like 100 false positives, honestly, because your regular expression is not really gonna understand if a piece of text is, let's say, inside a code comment or inside a string that is just printed out in itself or locked to a secure location. It's not gonna understand if this match is actually that piece of code. Like you can trip it up with just like white space changes, or you can even have false negatives, which might be even worse, where somebody is actually using a print function, but they did something really weird, for instance, in Python, where they renamed the print function elsewhere, which you can apparently do. So like, this is why regular expressions are never gonna be accurate enough and why we need something else. And like, if we dig deep down into like why we need something else, why regular expressions or string search is not the right solution, it's because source code is fundamentally not actually text. Like the source code that we write, it's just like an easy interface for humans to think about, because humans, we can like read text, we can read lines one after another. We are very used to that. We can write, we can easily type lines of code, but that's not what source code actually is. Like what source code kind of like fundamentally is, if you like try to start some sort of philosophical discussion, it's honestly the way that the machine sees it. And the machine sees source code as a syntax tree, as a tree, like you see on the right on this slide. So instead of being just like a string of words that regular expressions are made of, source code actually is a tree where you might have, for instance, one leaf node, which is like the function definition, which splits into two. It's like, let's say the name of the function, and then it's a code implementation of the function, or like another leaf would be the parameters that you give it. And so that's what it really is. And like what we always use day to day, it's like really easy to forget that like what we are looking at is not what source code is. It's just like a one layer above representation that humans can actually understand. And so instead of regex, like now we know that the right approach is matching a tree to find security bugs, because that's what's going to give you the most accurate results. And so there's already like lots of open source tools for this, like for various languages, really. There's PyLint, there's like GoSec and ESLint, etc. Like each language has its own tool for it. But so the problem with these tools really is that if you want to be contributing to them, or if you want to write your own checks for something that only your organization is working on, or like some security issue that is only typical to your organization, that is like specific to how you're using, architecting your own code, etc., you need to like understand, you need to be like an expert on how to navigate these source trees, these abstract syntax trees. You need to learn this one by one for every single language, because all of them are different. And like just to really illustrate what this looks like, I have this like snippet on the right that you cannot even read because it's so many lines of code. That's what it looks like in GoSec to just find calls to alt cryptographic functions. So like that's like a really simple check, and it takes 100 lines of code to be able to do it. It's okay that you cannot read it, because like we are not really trying to go into this like tree matching in depth, but like you have to understand that like if you wanted to implement something like existing tools that you might use for static analysis, it's that difficult. Like there's lots of things to learn there. Okay, and so like the main proposition that we try to be giving you as semgrep is that when you're thinking about analyzing code, when you're thinking about scanning security issues, it's the same way as you think about the code itself as you as a human. So like on the second line, you see what this actually looks like in practice. So when you're trying to find eval calls, my bad, you write a pattern like eval ... And that's like a super simple leap for us humans. And then semgrep does kind of like the translation to how to understand this accurately in the syntax tree. Okay, so like instead of those 100 lines, you write eval ... to find a function call. Okay. At this point, Peter or Timur, do you want to ask any details about like the background, or can we just jump into like
I had an idea to ask why was it so breakthrough idea to use AST, because AST was hyped like during in the recent couple of years. It was hyped, so it was just like a simple idea to implement. Probably why others, the big players of the field, didn't do that. So it's so obvious to go that direction.
Yeah, kind of. Yeah, that's kind of a really good question. And I can think of specific names. So like some other companies in the field have actually tried this. For instance, SonarQube specifically supports searching the AST, but it really took kind of like a really principled kind of like design discussion, like many design discussions to figure out how to make AST searching actually usable. So SonarQube supported searching an XML representation of source code for years. It's really like an old feature in SonarQube, but as somebody who at my previous company, I did use this feature, and it was pretty much unusable because all you can do is write an XPath query on the XML representation of the source code, which ends up looking almost like this thing over here in the right, except I cannot even use a proper programming language. I have to use an XPath query. So I feel like maybe nobody really just like tried to actually make this usable by regular like humans.
Jumping, like many obvious ideas, they are the most difficult to come with. It's like there's many things like when you've seen it is it's obvious. That's what we should do. And those ideas are quite hard to get. And another answer to this question is that this is useful really. You want a domain-specific language that is easy to use to express checks when you value a lot adding custom checks. And until now, most of the big players like SonarQube, Coverity, they had expert to write complex checks, complex analysis that were but very general, like finding pointer bugs, finding double free, finding deadlocks, these kind of very general bugs. But now we are switching towards like people use better API, they don't use C anymore so much. And now we goes more towards like simple checks, but of bad usage of certain API. And so these shifts also make it more important to have like an easy to write language to express complex checks. So that's two things. Yeah. Sorry to interrupt.
No, thank you so much. Yeah. We didn't actually introduce who just spoke. So that was Johan, the original author of all these three projects I've mentioned previously. So yeah, the man himself spoke. Okay. Do you want to hop to the next one? Next slides.
Please.
Peter? Okay.
Yes, please.
So what I normally do next is just show, like try to teach people how to write the most basic semgrep patterns. I think I'm going to do that at first, like we normally do, but because of these like special requests, I was asked, for instance, to show off the Visual Studio Code editor integration. We can maybe experiment with that a bit, which I've never shown off at a live presentation, but we will see what happens if I demo it for the first time. And we can also try the command line utility, the actual semgrep command. All right, so the way this thing works is we have this website for semgrep just for like learning how to write semgrep patterns, or even just like writing your own patterns. It's pretty comfortable for that, honestly. I'm gonna be using this website to show how to write the most basic patterns. And actually, this is the same thing that I've already shown in the very beginning. Here in this example, we just have a little Go snippet, which uses RC4 as a cryptographic encryption method, which is well known to be vulnerable. This is like too weak of a cryptographic function. So in like any kind of production project, you would typically want to disallow usage of RC4 entirely. And we're going to do exactly that. So like now this is like the code we are testing on. Like this would be the code that your team or whatever, like your student group or your company would have. And here is where we write the semgrep search pattern. So I'm going to just copy paste a bit of the code and run this right now. And you will notice that if this was just like a regular expression, it would, for instance, not find this line because of all the white space that was intended specifically to mess up the regular expression. And yeah, semgrep correctly highlights both of these lines. But of course, we specify that we only want to match where the key name is used for the first parameter. So instead, I'm going to say that this is like, this parameter can be anything. It's still insecure. So I'm going to replace that with a ... ellipsis operator. That's like the wildcard in semgrep syntax. And you can see, ta-da, now it matches all of these usages of the function. But also, semgrep correctly understands that, for instance, this line, which is a comment, or this line where we just print out a string which has this, is not actually an issue. So like semgrep understands the source code here and understands that this doesn't actually match what we were looking for. Okay, so this was the most basic example. I guess I'll just jump to like a couple more, maybe 2 more maximum, just to like introduce a couple other features here. So one thing that you can do like at this point when you have like a wildcard is instead of just like using a wildcard match, you can use capture groups, just like in regular expressions. So in this example, we are trying to find any usages of the unsafe package in Go, which you guessed it is unsafe. You shouldn't be using that in like production code. What it actually does is it lets you like sidestep lots of the memory safety guarantees of Golang and like muck around with the memory usage and memory freeing allocation yourself. Okay, so like this is what we had previously as well for finding all matches of a function. I'm just going to run semgrep and see or show that this works just like before. And that might be, yeah, okay, there we go. So it still finds the function matches, but there's another thing here. First of all, there's like another method that I would want to match. I will need a wildcard for this as well, just like disallow even unsafe.sizeof or unsafe.anything. And the other thing I wanted to point out is that like semgrep obviously, as any good analysis tool would do, like tries to print this message about like what it found. And so we're going to want to customize this message a bit. I'm going to go over to the advanced tab here. So while the web UI has this nice little input box where you can add patterns, like what semgrep itself uses is like these YAML rules. It's like here we just transfer the pattern to under a pattern key. And so we can actually find the message here as well. Now I'm going to, first of all, change the, let me zoom in. So like this would be a wildcard, but this time because I want to capture what it's called, I will say $func. And so what this $, and then the all capital word means is that this is a wildcard that will be saved under the func name for function, of course. And so in the message, we can use this match and say semgrep found unsafe func. That's no good. We're disapproving there. And so if we run this one, not sure why my internet is being so slow, but there we go. It correctly finds size of as well to find any other occurrence of unsafe functions being used. And now it reuses the meta variables here. And just like one more thing about these capture groups is that you cannot only use them for just like these messages, like that would be kind of boring, honestly, if that's all they were good for. What you can do with meta variables is also stuff like this. So like when you have a pattern which mentions the same meta variable twice, then it will match accordingly. So it will capture this left side variable in a comparison, and it will make sure that like both sides are not like both sides don't have the same one, because that would usually be a sign of some sort of silly mistake, like comparing the user input password to the user input password and checking if it matches, which is obviously not a good way to do authentication. Okay. And the last thing I wanted to show in like this basic tutorial, and then we can jump to whatever Peter wants me to write his patterns. I'm looking forward to the challenge. So in this case, what we're trying to do is find more than one thing. So like this is something like a security issue that we cannot express with just like one pattern. And so we're gonna go to this thing, this kind of pattern composition where we can enter multiple patterns, multiple search strings, and we can compose them in some way. Now, specifically what we're looking for here, let's see if this is gonna work still, yep, is insecure SSL configurations. So again, we start out by copy pasting the code, TLS config ... That means like any other parameters can be present as well. And we want to find where the minimum TLS version is set to SSL3, which is super old. You don't want that. Okay. This matches this incorrect configuration correctly, but this TLS configuration down here is also wrong because it skips SSL verification. So we also want to note down that like insecure skip verify true is also a bad kind of insecure configuration, because like you just shouldn't be skipping SSL verification. And the way we're going to compose two patterns to find both of these issues with SSL is adding them, both of these patterns. So like first is the SSL3 version. This one just finds whenever this is set to true. And you can see here that they are connected with like an OR binary operator. And there we go. Now we have matches if either one of these matches, like either one of these patterns matches. The other things you could be doing is pointing out a security issue only if something is like not equal to some other pattern at the same time as being equal to the first one. Or you could match, let's say like a function definition, a specific kind of function definition, like let's say an unauthenticated HTTP route, and you could check whether the other pattern is inside that one. So like that's a couple more ways to compose patterns. And yeah, okay, so these are the typical novice tutorials. At this point, I'm very happy to do whatever else Peter wants me to do. And I do have Javulna or Javulna already downloaded if you want to be scanning something specific.
That makes more sense to pronounce it in Hungarian. Although it's only understandable for Hungarians. Yeah, so this is a vulnerable Java application that I wrote for teaching purposes, and what I did was I run semgrep rule set on this code base, and I'm not really sure that I run the correct rule sets. You haven't yet talked about rule sets. Do you want to talk about them now, or did you want to talk about them later?
Absolutely. I always want to talk about rule sets.
Sure.
So yeah, let's skip over to like a bit more of a practical way of using semgrep. Like all I've told you so far is like, if you know about the security issue, this is how we can find them. But another big part of semgrep is that we actually have, like you saw like all of these YAML files that I've been writing for testing out rules, like various small rules. So we actually have a GitHub repository where we collect all sorts of rules from the community. Say hi to Sneaky Sherbert, by the way. That's my new tab page. It just gives me a new random cat every time I open it. So I'm going to go to the semgrep rules GitHub repository. And this is where we've been committing all sorts of security checks. Let's say like Go, language, security. And this should have a bunch of YAML files. Yeah. So for instance, using temporary files wrong could be a security issue. And this is the same kind of YAML file, the same kind of YAML rule that I've been showing previously. So these are the patterns. And so since we have this repository with all sorts of existing security scans or security rules, you can obviously reuse all of these that we've already written when you're running semgrep on your own. So like you don't need to write your own rules. And by the way, this rules repository, we just reached over 1,000 rules. So that's like a big milestone. It just happened like last week that with like all the community contributions and like our own work, we got 1,000. Okay, now to actually answer your question, Peter, sorry I took so long to like explain all that. So to figure out what sort of rules you want to be running on your repository, what I would normally do is go here to this rule sets page on semgrep.dev. So this is like a couple pre-made collections of rules. We basically just like went through, oh yeah, that's not actually the right page, my bad. Yeah, just stay on the explore page. The rule sets one has like all the rule sets that everyone has contributed. Anyway, like on this explore page, on this registry page, we've collected tons of like existing rules, both contributed by us in this repository, or maybe even like contributed by somebody else in their own repository. There's one specific one that I really like showing off because like I'm so proud of the Krisky. So this is somebody who just like really like somebody from the Golang community who really liked everything like using semgrep for scanning Golang projects. And he just went ahead and created like his own YAML files repository. And we added his rules here on the explore page as well, of course. Okay, so
open source. You can write your own rules.
Yeah. In fact, I think from the 1,000 rules that we have, maybe like 30–40% are written by other people from the community. Anyway, what I wanted to show is how to find a good rule set to scan with. Now, for most people, I would just recommend this one called R2C CI. This is like something that we put together as like the default most popular rule set that you cannot really go wrong with. It scans like almost all the languages that we support, including Java. And I'm just gonna switch over to the terminal where I have Yavulna already installed. Yeah, there we go. Hopefully everyone can see what I'm typing. And so what I'm gonna say is run semgrep on this repository with the configuration that I just copy pasted, which should be, yeah, R2C CI. My bad, you actually have to put p/ before it. It shows up on the page. I'm just gonna tell you right now that like whenever you see one of those titles, you put p/ before it for pack, rule pack, and we will run a scan. I will also open the page describing what R2C CI has. So we can like a bit better understand all of this stuff. So like for Java, here it checks, for instance, like this classic issue of whenever the left side of the equals sign is the same as the right side, and a whole bunch of, yeah, it has like 120 rules right now, 119, 20 of which are for Java. Quite annoyingly, it seems like the example issues don't show up, but we can at least see like all the parameters or the rules that were written. If you click like more info and see like these are all just the same YAML files that I've been showing previously as well. Quite interestingly, no findings from the 20 rules that we picked as like most important ones. That's a bit interesting. I'm just gonna try the Java rule set as well, which has like, I think, most of our high quality Java rules, but not only like the most important ones, like not only the ones that we are most confident that they are an issue. Okay, so now we actually have a couple more results here.
Mm-hmm.
We had 6 findings with like the default rule set for Java repositories. And I'm like, just for the viewers of this meetup, I'm gonna show you a little trick, an undocumented feature currently, where you are able to run all Java rules. Like this essentially means like run every rule from the repository, from the registry that starts with Java. So I'm just gonna do that. It's like an r/Java command line config value.
That is useful. This is something I was looking for. Like,
yeah.
Why
create...
I cannot run just all Java rules.
We should create some sort of nice web UI. It's just we were really worried that like if people run like all the Java rules, then they will probably like find some issues that are like false positives, even like with our YAML files. Like we are still just people, so sometimes we have like YAML files that match too many things because we didn't think about some edge cases. So like to make sure that people don't get mad at semgrep for being too noisy. And this is not the default way we tell people to use semgrep.
And these are rules which are located in the semgrep repository, I guess, but not in other open source repositories.
Yeah, this doesn't include the other ones. You can actually, for the other ones, your best bet is just to like go to the rule set and run that one, such as, for instance, for Java, by the way, there's like this one special rule set called findsecbugs, because findsecbugs is like an existing Java linter.
Yes.
And
it's pretty well known, and
and so for a couple linters that already existed, we had like either we ported the rules to semgrep patterns just to be able to like use all of those rules in semgrep, or like sometimes the creators themselves. For instance, there was this one for Node.js called Node.js scan. So the creator of Node.js scan, Ajin, actually ended up liking semgrep so much that like he rewrote his linter to use semgrep behind the scenes for most of the rule checks. And so in those cases, you can just go on the explore page and like run this, like maybe something that you're like already familiar with, because like if you're already familiar with findsecbugs, then you can just get those rules with semgrep as well.
Okay, so we have so let's see this, because it correctly finds an atop injection, which is great. This is a true positive.
Can you explain how? So this is something that's
because you can see that password and UID is just directly concatenated into an atop search expression, and password and UID comes from, but it basically comes from the user. And so
right there.
So if you just write something into the UID or into the password which contains some atop specific syntax, then it will change the syntax of the filter, and then you can, for example, search for other users' information through the atop or whatever. This is nice. And then it says that we have an SQL injection. There might be an SQL injection vulnerability in this code, but I think it's a false positive, and I don't even fully understand why it thinks there is some problem. It says it detects a formatted string, which is so as much as I understand, it just detects the columns in line 70 and 71 probably.
But we can check. Do you want to like figure out why this matches?
Yeah, maybe it's useful.
Okay, so like at these points, you can always just go to like the source of like wherever this came from. I'm just gonna go here where like to our registry repository, search for this rule, and we can see what the YAML pattern actually is. Oh wow, that's a lot of ways to do SQL injection. In that case, just because this would take really long to debug, like it's like such a complex rule with like different kinds of SQL injections, maybe we shouldn't actually check this. But I think, I think I see what happened here. So we think we worry about any SQL string where you use the plus sign. It's like here the SQL, like we find whenever the SQL that is executed is concatenated with a plus sign. And here you actually have
is there
plus
a plus
signs.
sign here?
Yeah,
Where?
on every line, on 70, 71, 72.
Yeah, okay. Yeah, but you see, it just concatenates basically.
Yeah.
Strings. So that's a false positive, which is okay, because every search, every auditing will always find false positives. There is no way to.
Yeah, I guess you just have to like have a human look at like whether these plus signs are actually okay to use here.
Yes. It's the thing is that if you concatenate string literals in Java, there is no way to have an SQL injection. The only way to have an injection is if you concatenate string literals with variables.
It's actually interesting and maybe a really good like learning experience here for us, because I want to see if we can match only when string literals are concatenated. Yes. I think it should be possible. So I'm just going to see how to improve this specific rule if we wanted to. And I will do that with the Visual Studio Code extension, which is super experimental, by the way. So like whatever I'm showing you right now is not even merged into a proper release. But I'm just going to open this file and find, yeah, that's where the query actually is. And I'm going to try to write a semgrep search pattern up here. So this is where I'm writing my search pattern right now. I'm going to say that this is like, let's say just, I'm going to find like create query occurrences on anything. Well, that's probably the pattern that we wanted to match. And so this might be, well, let me just check like what rule we actually matched most likely. So it was in create query. Yeah, there it is. So this is the pattern we matched previously. I'm just going to copy paste the exact same one to make sure that it still finds it.
Yes, good idea. Yeah.
Running this Java language. And let's see. Oh yeah, so this is where the results actually show up. This again, like this whole feature where you can see the findings in Visual Studio Code. We didn't release this. It's like a work in progress, but I'm just going to show it off right now. Okay, so it still matches that. Now I'm wondering if we can find any cases.
Probably, sorry, it makes sense to explain the pattern before you rewrite it for the.
That totally makes sense. Yeah, you're right. So this one matches any occurrences of the create query method. So like this W here is just there to match whatever the create query method might be on. And what we are looking for is the plus sign used for any of the parameters of create query. Oh no, actually it's like for the first parameter, I think. And like we add ... because like if you add anything else in create query, it's still fine.
Yeah, it's possible to give some properties to the create query methods which are not SQL. They are just like
it's like we added the ... here just to find those cases. Now what I'm gonna try to do is see if I can find only the cases where it's actually strings being concatenated. Like you said, that string literals being concatenated is always fine. So I'm gonna do is try to check if a string of ... added to a string of ... will match this line as well. Because if it does, and I think we don't have very good feedback of whether the search already ran. This is like more feedback before we release this feature. I'm just gonna run a different pattern to clear the results here. That actually doesn't clear it. More things to figure out here. Okay, the way I'm gonna know if like it actually ran and scanned again is by checking if the, let's say, I'm just gonna write like a random word here so we can see if the match says the same one, or actually I can click X here. Okay, so gonna search semgrep patterns with the string literals, and yeah, okay. So it showed up as a result. it actually is there. It shows like the new random word that I added, which means that we are correctly able to detect when it's only string literals being added to each other. And the reason this is really cool is because now we can compose multiple patterns. So like now we can add like a not this composition inside the rule. So if we go back here, the way to actually fix this false positive will be to add a pattern not attached to wherever we are checking for the plus sign here. And we exclude those matches where it's only string literals. So it's just a simple pull request to fix this false positive.
Yeah, great. Right now, however, we have another problem because because the thing is that I know that there is an SQL injection within the code. I think it's not in message service. It's if you show me the code, I will remember. It's probably in movie service.java or something like that.
Movie service.java. Maybe we should just search for like movie service Java, because like there were lots more results here. And I can check if there's any from movie service, but no, actually no. It seems like movie service doesn't show up. Okay.
And I might be wrong, but it might not be in movie service. Yes, this is. Now this is very. I understand that this is really difficult to find. Although I think I checked, and I think find security bugs actually finds this one, so it's not impossible, but it's not trivial to find it. What happens here? I think it's a very lifelike code. It very often happen. SQL injection very often happens when the conditions of your SQL are varying according to the user input. Like this is a search field. Okay, so the user can decide to search movies by title or by description or by genre or by ID, by none of them or by only one of them or by two of them. Okay, and if the user filled in the title input, then we append something to the to the where condition, which searches for the title. And if the user filled the description input, then we append something to the description. Okay. There are of course much better ways to do it than string concatenation, but still you can sometimes find codes that do it this way. And
so where's the injection here? I actually don't see it myself.
In the append, because the problem is that basically
like this is appended as like a this is like a string.
Yeah, this is basically a string concatenation, but it is hidden in string builder.append.
I see. Okay, cool. Yeah, sorry you had to explain it. I actually never wrote Java code myself, which I just wanted to mention also because like you saw that I managed to write a semgrep pattern for the language, even though I actually don't know Java myself.
Yes, that's a good thing.
Okay, so in this case, what we want to find is whenever there is an append to the SQL string with a variable, right?
Yeah, but of course you cannot be sure that the variable will be called SQL. This can be called anything. It's just
like yeah. Any string builder that ends up being sent to query.
Yes, that sounds good. Any string builder or string buffer, because sometimes string, but anyway, let's focus on string builder. That is end up being used in create query.
Yeah, I see. So I don't
think
think
there
we
is
have
some rules similar to.
I'll just search for string builder in any of our rules to see what this might be. So this one is for JDBC SQL formatted string. That might be actually very similar.
Yes.
String builder. So yeah, okay. So we actually have this one here where we find any string builder with like an append where a string and a variable is concatenated and then is sent to a query. Now I wonder if we actually just missed JDBC query. That would be quite silly. No, yeah, so this is Oh yeah, actually, so it seems like we detected when this is query for object, maybe, but not when it's regular query. So this is another like simple pull request that we could be making to this one.
But I'm not sure. Are you sure? Because
no, actually, I'm not. Yeah.
Because the thing is, if you go back to the rule, the whole rule has a pattern inside. It's if you just go back to the rule, please. Yes, you know, on the line 12.
Yeah.
Line 12, it says it has a pattern inside. GDBC equals new GDBC template.
Yeah, so it only matches if this thing is a JDBC template.
And it's a new GDBC template. It's created with instantiating a new GDBC template. But the thing is that in my code there is no instantiation because it uses dependency injection. If you check on the top,
yeah,
it is auto wire. So you will never find a new GDBC template stuff. And the question is, if you can write a search which says that something like the type of the variable has to be GDBC template or something like that.
Actually, yes. So we have type assertions. Maybe it's better if Johan answers this question because I haven't used type assertions myself, but it's somewhere here in this little cheat sheet on the right, I think. I need to switch to Java to change the cheat sheet. And let's see. Johan, do you know maybe how type assertions work in Java?
In Java, I don't know if it's like a cast syntax, maybe.
Yeah. Oh,
if you,
yeah, it's right here. Typed meta variables. Yep. Okay. So this is how you do it. The test code, I'm just gonna run, like put this right in here, even though it already shows the match there, just so I can play around with it. So I think this should work to find any variable that is compared to a string, just for like a really simple demonstration. Yeah, okay. So when you add like a type's name before a variable, a meta variable, that will assert that this is the correct type. So maybe we might be able to add JDBC template as a type and paste in this entire source code to see if it correctly understands that JDBC template is being used and that is a JDBC template type. All right.
Let's see.
Johan, will this work, you think?
Let's check,
right now there's no equal, so but you can
oh yeah, no, I'm gonna run like a correct actual yeah, so like whenever we run a query on a JDBC, oh wow, yeah. I have the wrong keyboard layout on my, on this keyboard. Okay, so like maybe by doing this, we can find any query call on variables like this. Let's see. I don't think that found it. Maybe if I do this before, that's how it becomes a full match. No, that wasn't it.
Maybe.
Either.
Also, this is not mandatory. It's just if you want, you can write it. Yeah, I think the problem is that the GDBC template in this code is a field. It's not a local variable of the method. It's a field, and probably that's why it doesn't find.
So it doesn't understand that this is
yes, that
type,
this is the same as the one referenced in the method.
Yeah. Well, that really was like a complicated example.
Yeah.
That it seems like we didn't.
Can you put back the code? So I mean, you can because I mean you do the happen. That the problem is that at some point you do a happen on SQL.
Yes.
And right now, I mean, if we remove the pattern inside condition, this will find the match, maybe, right?
Yeah, but then it will find lots of false positive because whenever you use a string builder and append something.
Yes.
But it also has to be sent to query or execute later. So I think it wouldn't be that noisy. See, like it also makes sure that it's sent to some method that is called query or query for object.
And there's a way, I mean, there's a indeed, like if you just use string builder, it's noisy, but if you manage to connect, and that's what meta variables are for, that is, if the meta variable used for the string builder at some point flows into something that is a type of JDBC template, and we have type assertion, and then you can replace the pattern inside that right now was made for.
Yeah, that makes sense. Yes.
Was made for some code that we analyzed, and in your case, indeed, you use like dependency injection, and so you need to make the relationship that, oh, there's a JDBC template there. We just don't see it right now because we were looking for certain things, and now there's dependency injection, so we need to change this pattern inside to still find it. For example, actually, you can do like in this example, you can maybe do instead of the pattern inside with that is a new. Where is the pattern inside actually? Yeah, here. Yeah, so this assumes that you can, for example, you can put a class. It's inside a class, right? And
yes, it is.
You can put class.
That's actually something I wanted to ask. Is it possible to use pattern inside to refer to a whole class?
Yes. So for example, you can do class $x. You don't care about the name of the class. Yeah, you can do it. You can do it. You can do it here.
Let's see if this will work. Class $x and then just the braces and dot.
And then you can put dot, and then you can put. You don't even need to. I don't think you need
GDBC
to put private. We can put GDBC templates
afterwards.
Yes.
Okay. My lack of Java knowledge is going to be an issue because I don't know if this is supposed to refer to this field.
No, to the type.
The type. Yes. Okay.
Just copy paste this line.
Yeah.
And dot probably no.
No, you need to. Yeah, you need to copy paste the declaration. No.
Yeah. Okay. This whole declaration here.
Yeah, exactly.
Okay.
But you know the name is very, very arbitrary.
That's why you use a meta variable. So the type should be always the same.
Okay.
And so the second argument,
the name
this one, you can put $x, exactly, semicolon.
Okay. And then semicolons.
Yeah. Then first, usually when you debug, it's better to debug first, like step by step. So you can the code is you're not sure that we managed to find the type, so you can put like just $o.query. Don't use the same meta variable first.
Okay. So I'll just check. Yeah. Anything query.
Yeah.
Yeah, like that.
Yeah, and
we will see if this. It's like this does find where we have a query.
Exactly. And so now.
Let's see if it finds that this is the same one that we declared as a field.
And so probably this will not work, but we can try.
Yeah, I don't think we understand fields properly then, right?
No, it's just that the type, the problem that here, I mean, you can try to put.
But why doesn't it work? I don't understand.
You can put this $GDBC should work.
I tried it. I don't think it worked. I also just added the semicolon. Maybe that's what.
Oh yeah, you remove the semicolon. This is yeah.
Yeah, it didn't work before either though.
Yeah, it's possible that that's a nice.
Okay.
So that's a nice feature to add, but right now semgrep does a little bit of type inference for Java and Go. Because in Java and Go, there is some type declaration. And so we try to, when we do type assertion, we try to propagate at the moment where you declare a variable, you put the type. So, and then when you use it later, when at the use time, there's not the type, but we can try to remember this kind of thing and propagate. But right now, like if the type is on the local variable and parameter, we do it. I'm not sure right now we handle fields, and so that's maybe, but that's you can create a bug report. The code is okay, right? We can, can bug report. Actually, create a bug report so then you can show people how to make a bug report. But
yeah, okay.
But that's a good example where we would like that this $$GDBC.query to be able to match. And it's still some, before being able to get the right check, there's still some path, but this with how we will debug things. That is, in the original rule, you had the pattern inside that was not adapt to your code because you use dependency injection. So you will modify this, put this class instead, and then modify slightly the rules, and then it will work on your code. It will be quite specific to your code because you use dependency injection. But
but many people use it in the Java world.
And then we can make this a rule. Like we can make a DBC.
So for that, what Johan said is what we always say, like when this should match, but it doesn't, you just click this button, file a bug, and it takes you to the issue tracker. You can honestly just even like submit it like this and we will figure out what your issue is. Obviously, it's nicer if you add a nice title, like Java, I don't know, like field meta variables don't match correctly.
Yeah.
And then we will probably fix it in like a week.
Okay, great. Yeah, that's really nice. I have never pushed that button, so. But it's really nice that it directs take you to the.
But it's exactly the right mind. That is, the right mind is that okay. You put a general pattern like string builder. It's too general. So you want to remove false positive, so you put extra condition, and you use this combination of patterns to put extra condition. And then you try to make the link between the two. And sometimes it will work, and sometimes it will not.
So yeah, like right now, I would recommend that if you wanted to run this in production right now without fixing the bug, this will be a pretty accurate rule, I think. I think it worked with J.
You still need the part that was in the original rule, which is like appending, like doing dot append on on the same string builder. But
I would use this one because like if some piece of code runs query on something and that class is using JDBC, then you can be pretty confident that this is an actual issue. And like you would just add like the string concatenation stuff.
Yes, that's right. Yes.
All right. Is it feasible for us to wrap up in like 5 minutes with maybe some audience questions?
Yeah, there are audience questions in chat. Could you please open that?
Oh, hey, there you are.
No, in the chat. First of all, in YouTube there are no questions.
Okay, but don't worry, I'll stop.
In Zoom, you can retract to blah blah blah. Integration with Github Actions. Is it planned?
Not only planned, it already works and it's fucking awesome. Honestly, I'll just show you right now. I don't think I have any examples here, but here's like all the integrations we have with Github Actions. First of all, we already published a Docker image. It's super simple. You can find it on the docs page of semgrep.live. And it's like a super simple workflow. You add it here. You just, this is where I've been testing it on like a random vulnerable repo. So I would just go to a random filled job. This was from like several months ago. So we've updated since then. But you just get a failed CI job and the logs for this have expired. Maybe I can show you like a newer one. Oh, well, this one doesn't actually have errors.
In the meantime, there is a compliment from Dominic. Seems a very interesting alternative to commercial SAST tool when a company team wants to start with SAST activities. Well, it's a question, but we can put it as a statement.
Yeah, I'm just going to try to find any failed semgrep jobs on the semgrep repo itself. And it seems like we have this one which failed.
And also Dominic noted that he cannot find the GitHub workflow file in the provided repo, or probably, it relates to the original repo, because in the meantime I provided the Yavon repo, and that may created a confusion.
Yeah, actually, I can't.
Does the tool support flagging false positives?
Yes. So the way you flag those is let's say we will say that this one was a false positive, and you just add a no semgrep comment to flag that this is not a correct match. You can even put like the rule ID there to filter it more. And on the next scan, when a semgrep CI job sees this, this will upload it to, well, I'm not supposed to show this because this is like a free web app that's not open source, but basically it will show up in a web app in like your list of all sorts of findings. It will show up as like an ignored or fixed finding. Yeah, it shows up as muted.
Okay, can we move to the next question?
Yeah, that's the AST one, broken code.
Yeah, since the system works on the abstract syntax tree, does this mean it assumes the code works, compiles, or does it work on broken code?
I am so proud of Johan because him and another core developer recently just fixed this. It actually is able to recover.
Yeah, and I'm proud. I'm proud of Daniel who asked it.
Yeah.
Okay. Yeah.
So it actually is able to recover from most. Well, I'm not sure if most, but it definitely is able to recover from some syntax errors. So like you could technically have probably a syntax error like this. Johan can tell you exactly what it works on. And semgrep the CLI will just report that it skipped some lines of code because it couldn't parse it. It seemed broken. And it does give you results from the rest of it. Yes.
There's two things. So first, no, it doesn't require the code to build. Is that we don't care about the build system you're using. So any Java code out there or Go code or out there, we don't care about the build system. We just parse it, and we don't need to know where are the, like in Java, it's okay, but in other languages, you need to know where are the header file, or we don't care about all of that. And so it could be broken. I mean, we are independent of the build system. And then broken code, I mean, why would you get broken code first in your repo? But yeah, we also handle some, if you have a few errors in your files, we just try to skip them. And so we start to use a Tricitor project from GitHub to parse some of this code. And Tricitor is a really good GitHub project where they do some good error recovery. And so sometimes they can skip some tokens and still be able to recover the structure of the EST. So
yeah, so here I just broke this file. I removed a whole bunch of important function definition string like characters, and so this is the result, the JSON result from semgrep. It says that it couldn't parse. There's a parse error between these lines and this lines, and I believe I don't know if in this case we actually recovered from this.
You can try to write a pattern and see if.
I'm not sure if I can do that in Java, but probably like I can.
Actually, Daniel extended his question with that. Also, what if pieces of the code compile, but the entire project build won't work? Can it search in the pieces that does compile without building the whole project?
Yes, and here it is demonstrated. So I actually just broke up here. I broke this code. This is now invalid syntax. And then I added an error where the same variable is compared to itself. And you can see in the JSON output here that the conditions equals conditions was found as an error. And it also mentions that it couldn't parse like one part of the file, and it just skipped those parts.
Yeah, we don't analyze the bytecode. We analyze the source code. And so we don't build it. We don't care about the build, and we analyze file by file. So if you have 10 files and one is completely broken, you will still get report on 9 other, whether or not they are part of the build. Yeah.
And probably the last question, yeah, Daniel, thanks, sends you his thanks.
Yay!
And
thanks,
not,
Daniel,
not the
for
last
question.
Yeah, and in the meantime, not the last, but the question: how would you compare semgrep to CodeQL?
Yeah.
There's a fact, actually, I think. There's even it's in the fact, I think, in the FAQ, sorry. I think.
Yeah, I mean, like, you could check like the proper corporately written response. It's actually kind of insightful. Personally, what I would say comparing to CodeQL is that CodeQL is pretty much almost the same as writing your own static analyzer in terms of complexity. The querying in CodeQL, from what I've seen and heard, requires like two PhD engineers to go out to a company to train people. Like this is literally what I've heard from one company.
Did Gabor Seljan wrote a CodeQL query? Oh, we cannot ask question to the.
I don't know if you can answer.
Yeah, Gabor, did you write any CodeQL queries ever?
Because you just wrote a semgrep query. But...
Yeah, again, this is what a semgrep query looks like, and yeah, cool. That's fair enough. If you're using existing rule sets only, then well, I haven't tried CodeQL like that. I think it's like pretty accurate. Like I cannot really say anything bad about CodeQL in that regard. But if you are trying to author or like modify, like, you know, if you inevitably have some sort of issue with the existing rules, like we just found as well, that they don't support one specific kind of SQL injection, for instance, then with semgrep, like I, as a person who cannot write Java code, pretty much could fix or change some of the rules myself. While with CodeQL, you honestly need like weeks of training before you are able to understand the CodeQL representation that they have for source code, or like the GraphQL thingy. So that's basically what I can say. But yeah, thanks so much.
Finally, can it be used on Windows?
I don't know.
I think so. Yes.
Jan?
Docker.
Oh yeah, use Docker for on any way you can get to run on Windows. I don't think any of us test on Windows. It's like we provided Linux binary, we provided Docker image. You can install semgrep from brew or pip. But I don't think any of us test it on Windows.
No, but probably on the WSL Linux subsystem of Windows should work. I mean,
yeah.
The code is written in Python and OCaml, and both are used on Windows. I mean, both target Windows. So.
Yeah, I think that, Dominic, the answer is that nowadays Windows has Linux in it, if you wish, and it just works better than any Mac OS in this respect. So Linux is like first class citizen in Windows, so it should be run there without any problem.
Either Docker,
it's just my general. Yeah, so you don't have to fight with the Windows command line, whatever
Dominic,
name it has.
You can submit the bug report on the repo for the Windows.
Okay, thank you very much. I will do it. I don't want to disturb you. It was just because I was playing with the tools, because to be honest, I think very, very interesting and very amazing. And I want just to try a little bit with, in fact, on an issue that I have met with a client today. So when I have tried the code snippet on the web UI, it has worked as nice. So it's really amazing. So I just want to use it on my Windows, but okay, I will move to the Docker. It's not a problem. Okay.
Sorry about that, Dominic. I see the traceback that you sent us. It seems like it has to do with like the fact that semgrep is actually of multiple components. There's like a really performant core written in OCaml, and what is called semgrep is a Python layer that just like invokes the other binary. It seems like just because we didn't test on Windows yet, Windows is unable to compute where to find all these binaries, or we don't install them correctly. I think maybe it is around time for us to start thinking about Windows support, because it might be easy to fix these things. We just never really got too many requests for it, so we didn't do it yet. Sorry.
Okay, I will just open a ticket just for the information.
Cool. So we will not support Windows. Wonderful.
Okay.
No, I mean we might never answer this request, but it's good to put it on our radar, because
you're too nice to us.
the more there's a sum up on an issue, and the more we care about. So
it's normal. Thank you very much, guys.
Awesome.
Okay,
but we
really
still
glad.
have a question. I'm sorry,
Oh,
Bence, because on YouTube we have a question. First, we have a statement. Awesome tool, and the question is: any plans for mobile apps, Kotlin, Swift?
Yes, Jan, do you want to take this?
Yeah, actually, one of our engineer is working on Kotlin, and so there's a tree-seater. There's a parser for Kotlin in the tree-seater project, and so yeah, hopefully in a few weeks, or I mean, there's Christmas, so hopefully in January or February we will support Kotlin and Swift. Again, you need to create an issue and to get some thumbs up, and so it's on a we handle languages on a priority basis. So
yeah, like all of this, all of the development and like the roadmap we have is like on GitHub, and you can easily search for these issues and figure out the state of these support, like language support questions. But I also wanted to add, just because this is a great thing, I don't want to go into the details, but I feel like for CodeQL, it takes like a year or so to implement a new language. I feel like semgrep, just because it's like such a simpler concept, a simpler implementation, it's maybe a bit less accurate in some cases, but like just because like we have a simpler concept for matching code, it takes us like months, maybe like 2 months or 3 months of work to support a language pretty well.
No, it takes
Okay.
it takes 2 weeks.
Okay, yeah, Johan is the one that actually works on it. It just
But I mean,
seems like, yeah.
there's different level of support. Like, but I mean, in 1 week, you got a basic support like $ meta variable and ellipsis at a few places. But then you need to iron some bugs. I mean, it takes 2 months to really coming from alpha to a good status. But yeah.
Cool.
Okay, may that help you. We could provide you with vulnerable Kotlin and Swift mobile applications that we have. Anything else? Could we wrap up finally? I mean, it was your wish, Bence, so I'm sorry.
It's like
continue, but
yeah, the rest of the team is in San Francisco, so I'm supposed to be working now. It's like regular daytime over there. Okay,
what I can promise is that I will a little bit polish the video and segment it to chapters or parts. I don't know how YouTube calls it. So you can refer parts if you wish, if any part of this chat was useful for you. I think that we achieved what we wanted. We achieved this non-presentation format and dialogue and almost a workshop style of meetup.
Yeah,
that was good.
Thank you so much, Timur, by the way. It's like, it was awesome moderation, and I'm really glad that you gave us this idea to challenge ourselves a bit and not just go through the slides. This was great.
If you wish, guys, we can return to it like a month later or something, and get Glenn and Ricardo from the Secure Knowledge Framework project to talk with us. They may have different views, and we can have another interesting discussion then. So, guys, thank you very much. It was an astonishing good meetup. We enjoyed it. I hope that this video will be used and watched later. Bence, many thanks to you for the presentation or for the talk. And Johan, thank you for the thing itself. It's really amazing. So let's move with it. Thank you very much, and let's wrap up. Bye.
Thank you. Bye.
Thanks, Peter, for the bug.
Bye.
Yeah, and thank you, Peter, for making it even more interesting for us. Thank you, Peter.
Thanks. You were great.
Bye.
Okay. Bye.
Bye.
Ciao.